It's not just using like an English word, you know. It is about understanding the true meaning and the definition of individual terms. Okay? Susceptibility. What is susceptibility? In English, I am very susceptible to. Yeah? But what's the difference between vulnerable? Sometimes we call I am very vulnerable now. I am emotionally vulnerable, financially vulnerable, right? No. Sensitive is sensitive, vulnerability is vulnerable. Right?
The composition of exposures.
No. So you don't go into the technical terms because many of you wouldn't know. Okay, that's why I'm trying to make you understand. Okay, vulnerable, susceptible, hazard. Hazard is hazardous, right? Dangerous, hazardous, right? But we'll understand more about risk. If you are not studying or you are not preparing well enough before your important exam, so you are risking into failing the subject, right? So the impact is much more higher. But the risk would be something to do with losses, right? So this is what we understand. So as we learn, we will learn more about all these vulnerabilities. Now let's look at disaster. Okay? Definition of disaster. Very good example yesterday. Okay, when the match was going on between India and Australia, had Kohli got out, that could have been a potential disaster for Indian team, right or wrong? Yes?
Yes.
But that disaster, was it affecting Bangladesh? Was it affecting England or Pakistan? No. So that means disaster is affecting a particular community. Okay? So now if you want to define what is a disaster, this is what actually is being defined as a serious disruption of the, please come. A serious disruption of the functioning of a community or a society causing widespread human, material, economic, or environmental losses which exceed the ability of the affected community or society to cope using its resources. Okay? Are you reading it? So very simple language it is being defined. That means a serious disruption that is happening to a society whereby there are potential losses and everything. The society cannot be able to cope with the situation. Then that is what we call a disaster. That means the key word is the community, right? And the coping, right? Two things. But let's say another 3 or 4 batsmen are there, as good as like Kohli. Then the disaster in making, obviously, the potential will be much more lesser. That means the coping capacity would be much more higher. Understanding or not? Yes. Yeah. Japan. Every month they have earthquakes. I have experienced earthquake in Japan. I have experienced earthquake while giving a keynote talk in Taiwan. Okay? So the entire stage started actually tumbling and the screen started tumbling. But the Taiwanese, they're calmly sitting and listening. The other people, they started running. Right? I stopped my lecture because they know the design of the structure is good enough actually to withstand the vibration. Yeah? The sway of the building and everything can be withstand. So coping capacity is much more higher. But our buildings here collapse. So the coping capacity is not there, right? Isn't it?
Yes.
So slowly you will understand. The coping capacity is the most important thing here. Now, if you would like to go a little bit deeper, we can say that it's an extreme phenomenon, right? Of different origins. So when I say origin, that means the triggering mechanism could be anything, right? The triggering factor can be of anything. Okay? What is triggering factor? Triggering, if a landslide happens, what is the triggering factor? Rainfall? Yes. Then earthquake? Yes. So these are the triggering factors. You understand? Very good. Okay. And so disaster, we can say it is an extreme phenomenon of different origin of large intensity. That means the intensity is very high. Okay? Which can be measurable quantities such as earthquake intensity, water depth, okay, or depth of landslide, or how long actually the spread of the landslide, or if there is a rock fall, what would be the distance that actually the rock has been detached and transported, and so on, which can be quantified. Okay? And limited duration. Okay? Now imagine if something happens of very high intensity and stays there forever. Let's say earthquake would happen 9.5 Richter scale for 3 days. What would happen? Japan ka baap bhi udhar kaam nahi kar sakte. Right? Isn't it? So intensity is very short duration. Okay? It's a good thing because when the intensity goes up, basically the duration remains short. Okay, the intensity drops, the duration becomes long. Right? So this is what you have to understand. Okay? And occurring at a specific location. Earthquakes, does it occur everywhere? No. It's a specific location. So that means it is a spatial problem. Spatial means what did I say? Location, location, location. Okay? So occurring at a certain location, involving a complex interplay between physical and human systems. That means there is a relationship between, there is an interaction between the nature and the human systems, us, anthropogenic activities. Okay? If earthquake happens, like when earthquake used to happen maybe a million years ago, did it matter? We didn't know when there was any communities was living or there was human being living there, right? It can happen at high intensity for longer duration, who cares? Right? Isn't it? Are you understanding? So, but earthquake, if you see that we are not responsible for earthquake. It's an endogenic process that is happening. Endogenic means within the earth, inside the earth, right? We do not have any control of it. It would happen when it happens. But what we can control is that how to design actually to cope if it is coming in different Richter scale, right? But if that is about earthquake, but how about floods? We are responsible for it. Unplanned activities, okay? Unplanned land use, okay? Inadequate drainage system, okay? Chopping of the trees, okay? Which creates actually a nice ecosystem balance, right? So we are solely responsible for it, okay? So you are understanding, right? So involving a complex interplay between physical and human systems, causing loss of lives and threats to public health as well as physical damage. So disaster means it has to be having all these components. There has to be physical damage, or causing losses to lives, or threats to the public health. And disruption of the livelihood systems and society. That means there is a disruption of the society. Right? We had the tsunami 2004. That was a disruption of the society. The Chennai flood that happened a few years ago, I don't exactly remember. Okay? The Chumoli earthquake that happened in 1999. I had visited actually the site, the entire site immediately after the earthquake. But at that time I was in Kanpur, and we felt it. The tremor was felt. Okay? Delhi earthquake, Delhi dam failure, right? So these are actually disruption to the society. Okay? So that is what, so you have to remember. So when you establish the parameter, that is how you have to establish your parameter. Which parameters, which variables, which conditioning factor that you have to use for your analysis. Okay? Very important. And exceeding local capacities and resources. So you want to know? Exceeding local capacities and resources. Acha. That means whatever capacity that we have, that is exceeding. That means it's becoming like mind-boggling. We can't cope. Okay, and requiring outside assistance to cope. That is what actually, when all these criteria are being made, that is when we call a disaster. Okay. Now imagine there is an important exam that you are going to, and then your pen is not working. Right? It's a disaster. But for you, for your family, that's not affecting anyone else. Or maybe your friends to a certain extent, if they are good friends. If they are jealous types, they would be very happy.
Yes.
Okay? So now you see, you understand? Are you understanding? That means it is a community, always to whom. That is what actually need to be addressed. Okay? Look at the figure on the left hand side. So there are two things that I have mentioned here. One is hazard, one is vulnerable. Vulnerable is always is society. Who is vulnerable? Okay? And vulnerability is essentially something to do with socio and economic. Okay? And you can do a vulnerability assessment without having to address any susceptibility or hazard assessment. Okay? You can still prepare a vulnerable map or vulnerability assessment. When I say map, that means it is like end product sort of thing. But the process is called assessment. Modeling, you can say. No, vulnerability modeling or vulnerability assessment. Assessment is the right one. Okay. So meaning to say here, we can actually off this light here a little bit. Because that has to be clear, not me. They can have. Yeah, that is better. Okay? मुझे देखने की कोई जरूरत नहीं, ये देखना बहुत जरूरी है. Okay, ठीक है. तो फिर you see, if the hazard is high, but if there is no vulnerable society, the risk is not there. There is not a disaster. Hazard can be extremely high. Let's say massive earthquake happens actually in the central belt of Himalaya. Okay, but no one is living there. Okay, no community is living there. It's not a disaster, but the hazard is very high. Okay, so hazard is high, and when there is a overlaying on the vulnerable society, then it becomes a disaster. Clear? Now, this is what actually. So this is the high risk. That means this is the first high risk area. That means high hazard, high vulnerable society becomes a risk, and when the risk, they cannot cope with whatever resources that they have, that it becomes actually a disaster. Okay? Understand? So these are the fundamental steps that how you do the assessment. Okay? So that means you have to do the hazard analysis first. You must do the vulnerability assessment first. Then you determine actually or estimate the risk. Then you do all those assessments to determine whether it is a disaster. Disaster you can only define after the event has happened. Or you could also speculate it is going to be a disaster, like that. And it is always being determined in terms of probability. Okay? All hazard, vulnerability, everything, risk, always being determined in terms of probability. Probability means what? Between 0 or 1. Okay? 1 means the probability is very high, 0 means very unlikely or no. Are you all getting me?
Yes.
Okay, good. So I have given actually, anyway, today I'll give you all these slides so you can go through. I have also put some assignments for you. When you have time, go through it and do it as well. In the tutorial, you can do it as well. Okay? Tutorial classes. See, I have put here. Okay, now, there is one question here I put here. Very short question, duration 5 minutes. You don't have to answer, but let's go through one by one. Okay? Just to understand more about it, more about the definition of disaster. When you will become ill, you cannot work anymore. Is it a disaster? It's a disaster. Depending on actually the family situation. Yesterday also I did mention, if your spouse is working, you come from a very wealthy family, okay, it's okay. Okay, there are a lot of rich people's son or daughter, they don't have to work. So again, those definition has to be in play. Then, when a famous Indian cricket player, okay, is injured and misses the most important match, and the team India loses the world championship. Disaster. 1.6 million people rattled. Tears are being shed. Right? That's a disaster. Emotional disaster. Mental disaster. Okay? Now, when does a car accident become a disaster? The annual financial cost of car accidents in the United States is estimated to be around $230 billion annually. $230 billion is quite a lot, you know. And with 2.9 million injuries and around 43,000 casualties. It's a lot. Okay? They have better highways, obviously. But obviously they have more freedom and so on. But in India also we have many accidents, okay? The death of 2,970 people in the attack on the Twin Towers on 9/11. It's a disaster, okay? The financial crisis that hit in the world in 2008, it's a disaster. And right now, so whatever is happening, it's a disaster, right? Isn't it? 2 weeks ago, the market tanked, lost about like last week, Australian stock exchange, I think, what, $100 billion wiped off in a day. Just in a day. Okay? So you can also come up with other examples that illustrate that definition of disaster. Okay? But make it a bit, we will discuss more about once we go into the tutorial. So think of this, okay? Come up with some complex scenarios. Thinking is the most important aspect here. Now, let's look at the types. Different types of disaster. Okay, but remember, disaster, you cannot call it a disaster until it happens, and if the society cannot be able to cope with it. Okay? Now, so broadly it has been classified into 3 types. Natural, human-induced, and man-made. Okay? Natural is what? Meteorological. It can be also called as meteorological, or it can be also called as geomorphological. Right? Meteorological means weather-driven. Okay? Such as what? Drought, dust storm, flood, lightning, windstorm, thunderstorm, hailstorm, tornado, cyclone, hurricane, etc. and etc. and etc. So these are the meteorological meteorological type of disasters. But these are basically triggering factors. Also you can call disasters. Meteorological is the triggering factor. Now, geomorphological and geological, earthquake, tsunami, volcanic eruption, landslide, snow avalanche, glacial lake outbursts, land subsidence, groundwater pollution, coal fire, coastal erosion, and etc. The list goes on. I just put a few examples. Ecological is crop disease, insect infestation, forest fire, mangrove decline, coral reef decline. This is human induced. Right? Why? Coral reef declining, why? Because the sea surface temperature is increasing. Why the sea surface temperature is increasing? Because of global climate change. Why global climate change is happening? We are responsible for it. We are burning too much of fire. Okay? We are releasing too much of carbon. Right? Isn't it? So that's how you have to find your variables. So GIS, we have understood that you can use any sorts of data. But if you do not know what sorts of data, it's a disaster. Okay? Alright? Are you all getting me? So these are the things. Then technological. We are responsible for it. It's not actually human-made, human-induced. We are responsible for it. Like armed conflicts. Okay? The wars that we are having. Right? This has nothing to do with nature. Because we are fighting for it, right? Then traffic accidents, okay? Nuclear chemical accidents, oil spill, everything. So it is all man-made. It's supposed to be here. This is supposed to be here, okay? Human induced is thus this one. But again, there is a little boundary between that, because sometimes we can also say it's human induced. But mostly I would say they are man-made. Okay? And then you have extraterrestrial. That is, you can say that is God's make. Let's say we are walking in the field, suddenly a meteorite comes and hits us. Whom to now blame? Right? So that is what you call extraterrestrial, like asteroid impact, aurora borealis, and all those things. I'm just giving a few. Okay. Now, but if you look at actually this particular table that I have mentioned, but disasters are almost never natural, because even this also, it's not natural. They are not never being actually natural. The cause can be natural. Right or wrong? The triggering factor could be natural. But as such, they are not actually natural. Because how can it be natural? If you think about the definition, it has to be disruption of the society, right? So it is, are you understanding? Except the earthquake. But again, if you are well prepared for it, like Japan, it's not a disaster. But the cause are natural. The cause can be natural. Are you getting me?
Yes.
Okay, good. I'll give an example of an earthquake that happened actually about what? 15 years ago, I think, in what is the name of that city? Sichuan, I think. Okay? What happened in this place? There was an earthquake. So first actually the earthquake happened. Okay? Then once the earthquake happened, that led actually to landslides. Almost about 800 landslides happened due to the earthquake. See, earthquake has already happened. Obviously it has destroyed some buildings and blah blah blah. On top of that, landslide also had happened. Plus, when the landslide happened, and then there was a break of the dam. So you see, one triggering mechanism, but it has led to cascading effect. Earthquake is the only triggering factor here, but it has led to the landslide, it has led to the flood, it has led to the dam failure. So if you are addressing just about one type of hazard, okay, this itself is a disaster. So therefore, these days they come up with multi-hazard assessment at the same time. Okay, but in this scenario, let's say something like this happens. Okay, and there are also debris flow as well, destroying the remains of the. So पहले ये आया, पहले ये आया, rockfall आया, जो बचा कुछ थे इधर, जिसमें गया debris flow. Right? This is a serious disaster, right? So 4 million people, they were being displaced actually to the tent. 4 million people. So where they are going to go? Right? So obviously they couldn't cope, right? So now you can see the definition of a disaster. Okay. Now, very important these concepts to understand. Let's go through geohazards. So I have selected about 4 or 5 types of geohazards so that we understand the mechanism behind these processes behind these geohazards. First is landslide. On the left hand side, I have put actually certain characteristics, triggering factors, spatial occurrence, duration of the event, time of onset, frequency, magnitude, and secondary events. Okay? Triggering factor, it can be exogenic or it can be endogenic. Exogenic means on the surface of the earth, which can be triggered by the meteorological, excessive precipitation, excessive rainfall. Okay? Heavy rainfalls, land degradation, weathering, erosion, that also could lead to landslides. That is what we call as exogenic processes. Or it could be endogenic, which is earthquakes. Or it can be also man-induced. Deforestations, wrong land use plans, etc., etc. So you see, the triggering mechanism can be of 3. Externally, endogenic, exogenic, or both of them actually externally, and also could be man-made. Okay, because we are so much building concrete, right? So we are not leaving any natural soil, which is supposed to be like, so it's supposed to allow actually the water to infiltrate, right? Last year, September or August, there was a massive flood in Dubai, which has never been happened before. Dubai, it's a, so the Dubai is the biggest TV station. They made an interview with me just to know that what it would have actually triggered for you. Okay, and what are the technologies that we can use for? So because you see, sand, which is a quick, the infiltration will be much more higher. What they have done is basically everywhere is concrete jumps out. Okay, so the amount of rainfall comes in, so it just can't go, and one go, where to go, right? So that's why actually the flash flood happened. Okay, I think the airport was shut for a few days. Have you read?
But even the rainfall also, I think,
was excessive. But in the past also it had happened. Also in the past it had happened. Okay. Now, spatial occurrence is, spatial means always is the location. Okay. So slope areas with previous landslide activity. So sometimes what happens, some of the landslide which has happened in the past, but they can actually reinitiate the process as well. Reactivation of the old landslide also can happen, or new landslide can also happen. When the slope fails, once it hits actually the saturation point, right? If it fails, then obviously you will have landslide. Duration of the event, very rapid, that means from seconds to minute, but there are also some landslide, they are very slow moving landslide. It takes about years. Slowly the soil actually moves. Okay? But in that case, obviously, you have much time, much more. Last year, we had a massive landslide in Kerala. You think I don't know sitting in Australia? Okay? There's a massive landslide happening in Kerala. So time of onset from seconds to months. That means to process actually, to kickstart the process, it takes about seconds to, it can take also months. Frequency magnitude, it depends on the location, but they follow on inverse relations, obviously, always. When the frequency is very high, the intensity is very low. Yeah, otherwise it's a disaster. We can't go. Okay? Then, secondary events, it also lead to the secondary events. They can trigger floods if the body falls into a river. Fires in cities also it can create. Tsunamis if they fall into the water bodies and the dimensions are sufficiently large enough. Okay, so now, if we are working on landslide, we must know all this. So based on this, we can only find what are the suitable parameters that we must incorporate in our assessment. Okay? What's this back? Okay, this landslide. Is it happening because of the excessive rainfall, or is it happening because of earthquake activities, or both? Like sometimes we build new highways and we live actually in the mountainous area and we leave the slopes unattended. So they are all being exposed now to the weather. But I mean, and after some time, obviously, they are very, very susceptible to failure. Okay? Understand? Landslide. Now, with these important parameters, let's look at another type of hazards. That is called floods. Okay? What are the triggering factors here? Two again, but mostly it is exogenic. Okay? But endogenic also happens, like just now I showed you the example of the China earthquake. Right? So in this case, heavy or elongated spell of rainfall. Spatial occurrence, it can be of three types. Flash flood, this means very quick. Okay? Valleys bottom in mountainous areas, that is where actually the flash flood happens. Small inundated areas, but very quick. It comes quick, it goes off quick. Flash flood. That's why it's called flash. Okay? Then you have river flood. River floods basically are seasonal flood. You can call this a seasonal flood. That means river bank flooding, right? So we know that, okay, every year monsoon area, monsoon time or whatever, these are the areas we always flooded. Okay? So floodplains, large areas up to hundreds of hectares. Now then you have dams or bank failure floods. Okay? Randomly, wherever rivers are located, dimensions varying according to the location. Okay? Duration of the event? Rapid, from less than 1 hour to few hours for flash flood. Effect is flash flood. Whereas in the river flood, from less than 1 day to up to 10 days. Okay? So duration is also very important. Time of onset, from seconds for the DFF to few days for the river. And also for flash flood also it can be just very quickly. Half an hour very high precipitation or 1 hour for very high precipitation. Okay? Frequency magnitude, again it's an inverse relationship. Mostly you would find actually the relationship between frequency and magnitude are inversely proportional to each other. Okay? Secondary events, it could lead to potential landslides. Okay? Are you all understanding me or just moody? Okay, then I will give an exercise. Define these parameters for one type of geohazard. We'll see how. Okay. Earthquakes, triggering factor is 100% endogenic. Okay? It happens because within the earth. Okay? Tectonic movement. Spatial occurrence depends on the magnitude from local to regional scale. Imagine the tsunami that we had in 2004. How many continents actually were, how many countries were affected? It started out from west of Dhanbad. Then it affected actually all the Southeast Asian countries, Malaysia, Thailand. Okay? Then it also came to Sri Lanka and also the coastal area of Tamil Nadu, India, southern India. Right? So imagine, it can also be continental scale as well. Duration of the event, rapid, less than 1 minute, obviously. It doesn't stay for 3 days or 4 days or 5 days. Otherwise, you would be just like this. Okay? Time of onset is null. Frequency magnitude, again inverse relationship. And derived events are earthquake can trigger tsunamis, landslide, debris flow, floods, fires, etc. It can create many kind of secondary events. Okay? Now, let's look at the volcanoes. Triggering factor, endogenic obviously, because of the tectonic movements. Spatial occurrence, localized in particular locations, because we know exactly actually where it goes. It's not unexpectedly, we don't have a volcano in a new location, right? We know that these are actually the dormant volcanoes, sometimes they get reactivated. There was a volcano that happened early in the 18th century. It's called Krakatoa. Okay, in Sumatra. In Java. Okay, Java Island. It was told that the amount of gases that it released and pyroclastic materials that it released to the atmosphere, there was no summer for almost 10 years. And Europe went into total drought conditions. The weather pattern totally got changed. In Southeast Asia, like Malaysia, they used to have snowfall. Okay, just one event. Okay? So, they can be very, very catastrophic. And obviously, the pyroclastic materials that it releases, it has very thin needles. Okay, when you inhale that, it can cut your lungs. You don't even realize it. Right? So, then Spatial occurrence is in particular location. Duration of the event from minutes to years, obviously, because there are dormant. How many of you have visited any volcano? No? No? Oh yeah, we don't have, right? I visited some Arctic volcanoes. In Java, that is called mountain called Mount Bromo. It comes from the name from Brahma, so it's called Bromo. And you can see activities, and you have a lot of this gas that is being what do you call this? Sulfur. Okay. Then also I have seen another active volcanoes in Hawaii. Okay. Frequency magnitude depends on the characteristics of single volcanoes. Secondary events, obviously, it can have a lot of secondary events like lava flows, then debris, mud flow, landslide, earthquake, everything can happen. You can imagine. Okay, it can be very, very catastrophic. It can be. Okay, now think of. I just mentioned about 3 types. How about fire? Okay, let's do this activity. How about fire? Think of it. Fire. You can put this off. Fire, okay? Endogenic or exogenic? Both? If it happens actually, what you call earthquakes. Earthquake can also lead to disruption of actually the electric lines. They can also create fire. And also volcanoes directly anyway. Right? And then obviously exogenic. And who is responsible? We. The dry. During the dry summertime. Yeah, mostly.
Even sir, thunderstorm.
Thunderstorm? Yes. Exogenic. Okay? 18 years ago, we developed a system. It's called Southeast Asian Fire Danger Rating System that is being currently used by the Malaysian government to monitor the fire on a daily basis using the remote sensing based technologies. 18 years ago. On a daily basis, we used to track the entire ASEAN region. ASEAN means the neighboring countries of Malaysia as well. Singapore, then you have Philippines, then you have Laos, then you have Thailand, then you have Cambodia, then you have Vietnam, then you have Indonesia. Because we would also like to know where is the source. Because you have a lot of haze during the summertime. And when you have excessive haze, the air quality drops and the visibility also drops. So the school has to be closed down because of the air quality, API quality goes down. Okay? So you got to plan, you got to manage everything. Okay, now, spatial locations depends. It can be a few hectares, it can be up to like what you have seen in Californian forest fire, or the 2019 Black Summer that we had, the bushfire in Australia. It killed about what? 1 million koalas, or more than that? 4 koalas, yeah. And then, what are the things we used to have? I forgot. What are the parameters on the left hand side? Duration, onset time. Okay. So think of it. We are not going through in detail, but think of it. So any kind of geohazard that you are going to work on, obviously that particular table you need to create first, because from there you know that which kind of data set that you would create. Okay, don't follow the other people because every region is totally different, and the mechanism or triggering factors are also different. Okay, just because in the literature they have used that we use no. Okay, because sometimes it can be very site specific. Correct? Okay. Now we have understood that disasters are spatial features. That means its location is a must. Okay. This is the world map. You can see here. Okay. And what they have done basically, based on the some of the geohazards, they have demarcated into different cover zones. Okay. Essentially, the main objective of our 2 weeks program is for you so that you can prepare a colorful hazard or risk map by taking into consideration of the some of the inputs. That is what supposed to be used in a modeling. Okay. Now, this I have already mentioned. Okay, this is a website that I mentioned. It's a very, it's an insurance website, but they update actually all the list of natural hazards that happens around the world. Okay, all right. Visit the website. Use the GIS ability to view the hazard situation in one country instead in the country profile. So for India also you can be able to see. Okay, now it's not working. Oh, have to close it. This is very smart. So disasters and development. Some people think that in the developed countries, no disasters. No, it does. Okay? You see, obviously, but the casualties are more in developing countries because of lack of resources and the preparedness. Okay? Now, if you, 1999, there was a massive cyclone that happened in Odisha, coastal belt of Odisha, right? 1999. Right? Now, after that, if you look at actually the number of casualties, has almost become like last year there was one cyclone, but the casualty was 0. Because why? The government also learned from those exercises and they got better prepared, and the dissemination of the information is also getting much better and better and better. That means at the end of the day, your findings are being released to the people. You are alerting them, you are displacing them before actually the event happens, so that you are reducing the casualties. So ultimately there should be 0 life loss. Okay? So, but disasters are not just limited to the developing countries, they are also being happened actually in the developed countries as well. But the effect is much larger in the developing countries. Okay? And why? Because they have this disaster risk management planning. DRM means disaster risk management. That means you manage the risk. Like we say, just manage. What? Don't bring your problem to me, just manage. Right? You got to manage. Right? So you can see here, look at this particular graph here. Here is casualties, here is the level of development, and here economic losses. So when the level of development happens, obviously, what happens? Huh? Yeah. The economic losses would be, casualties also is going to be dropped. Right or wrong? Right? So the preparedness has to be there. So when you do the disaster risk management, obviously, you have, that means you can prepare long term, medium term, and short term. Okay? And also real time. Long term means 30 years, 20 years, 10 years planning. Medium term means maybe a year. Short term means weeks, months, depending on the type of hazard that we are talking about. Or real time, as it is happening. Your response, your mitigation ability, and so on. Okay? So you can't be able to see, but these are actually the, based on the income group, these are, how the disasters being located. Anyway, we can go through. This is the famous, the figure for disaster risk management cycle, or what we call DRM cycle. You can see on the right hand side. So this is the disaster cycle. Okay, it has many components to it, from before, during, and after the disaster. Okay, so before means community preparedness planning, Okay? Basically, you've got to prepare yourself if an event happens, like before the monsoon, you prepare, right? This year, what would be the likelihood of the rainfall and blah, blah, blah. You know, what is going to be the, which are the areas are going to be inundated and all those things. So the preparedness is very important here. So in the preparedness, obviously, community planning is very important, right? Then you have prediction and warning, right? That means you come up with the warning tools. Like if the river, let's say if the river, in this much amount of rainfall happens, consecutive rainfalls, let's say 2 days, 3 days, okay? Then what would be, then you issue the early warning. This particular village, this particular area, this community, be alert, because you can be, you know, underwater, right? So those kind of early warning and prediction has to go in. Then you give the response, especially when the disaster happens. Okay, when the disaster is happening, that's how you respond. Like what? Sending out all your resources to mitigate, to address, not to mitigate, to address actually the communities that is already been suffering actually from the disaster. Okay? So obviously this is where the resources comes in place. Okay? In Australia, if you have, let's say, a traffic accident, I think within what, 5-10 minutes you would be attended. If not, the helicopter would come to rescue. Okay? So when you are going to swim on the major, what you call, Australia is very famous for beautiful beaches, right? So there would be every 1 hour, 30 minutes, there would be a helicopter flying around. Because if there is any shark being spotted, or if there are anyone is in danger, and so on. That's how they value actually the human life. Okay? So that is called preparedness. Okay, estimating. And if they know that, okay, the season is like that, the current of the ocean current, or Pacific Ocean current has changed, and maybe there is a likelihood of, coming of the shark, then they would give actually necessary warning. And every beach would have a response team, a designated response team. That means there would be flags between this particular zone. You must swim or whatever activities you want to do. We don't have, unfortunately, in India, because we like to explore things on our own. Okay, but what I meant to say is that basically these are the what you call the preparedness, warning. Okay, in a smaller scale. Okay, now a response, that is how actually they respond. Recovery, once actually the disaster happened, then how to do the recovery activities, bringing the life back actually to the normal situation. Okay, sometimes it can take years to rebuild everything, right? Then this is where actually the risk assessment comes. Risk assessment, the most important thing, you have the hazard analysis and vulnerability analysis. You understood one of the previous slide? But to do the hazard analysis, it is very important to know the history of hazard that has happened in the past. Because हम तो ऋषि महर्षि नहीं, हम ध्यान करके बैठ जाएं, and then we find some findings, and then we say, okay, ये हो जाएगा. No, that's not like that, right? So our approach has to be systematic approach, scientific based approach, right? So that is why you have the disaster history is also very, very important. And when I say history, that means archive. Okay, the inventory of the longer the duration of the history that you have, the better data that you can prepare. And that means machine learning can be used more, because machine learning loves actually more data for learning. Okay, again, what model to use depends on this. Not just any damn thing that you can use machine learning. No. Whether to use a physical based model, you know, right? Physical based model, that is the traditional based model that you use, for example, hydrological model, hydrodynamic model, okay, or factor of safety model, right? Those are physical based models. But obviously they are too much data dependent, isn't it? Because you have to go to the field, collect a lot of data, bring the data, analyze the data in the lab, okay, calculate the equations and all those things, right? And they are very, very site specific. Small site you can do it, but when you are trying to do it for a country scale, it's very hard. But these days, that is why there is an ensemble of both physical based approach and the data driven based approach, or machine learning based approach. So you can make the best out of it, optimize it. Okay? Alright? So the history is important, and the history is important, not only the spatial footprint, but also the time stamp. When did it happen and where it was, had it happened? Those two important aspects you need to capture. It's not easy. Let's say if you are working on landslides, okay? Now you have to create actually a landslide database for your particular area, right? How do you get it? Obviously now we have some agencies who are collecting this data, but when you look back historically, there may not be any data. That is why the remote sensing data also will be useful, because we have also archive image bank, right? Then you can look back through those data, analyze them, do the change analysis. Okay, in January this was the situation, but in August there is something has happened here. Now there is a slope that looks like it has failed. With 100% surety you can't tell. So then you have to do the verification. Then you start collecting the secondary information, that is what I was mentioning. Remember yesterday I did mention the secondary data collection, that's where it comes in. Newspaper cuttings. Any other, go to the community, ask them the community. 4 साल पहले इधर कुछ हुआ था. Then they will tell you, there was a landslide that happened. Then you confirm, yes. Then you do the marking spatially on your database. Understanding? Are you understanding? Okay. So history is important. Then you go for scientific assessment. In order to do the hazard, hazard is basically, the output of the hazard is basically when and where. Okay? But before doing that, you have to do first where. Where likely it is going to happen. Which locations are susceptible. That is why the term susceptibility assessment comes in. So first you do the susceptibility assessment, then you do the hazard assessment, then you do the vulnerability assessment. Vulnerability assessment is totally independent. You can do at any time. That doesn't matter. So then once you calculate the hazard, then you bring your vulnerability, then you create your risk. Okay? I told you this is very important. If you don't understand this, it's very hard to understand the subsequent cases. Okay? Alright? Now let's go a little bit deeper. Mathematically, let's derive. So far we have not spoken about mathematics. Okay? So risk, if I want to define, in a function, what happens is that, simply we can say that probability of losses occur. Right? We have seen the definition in one of the slides, but now if I have to derive an equation out of it, right? So I can safely say probability of losses occurring. If I want to break it down further, risk would be hazard multiplied by vulnerability multiplied by amount. Quantity. Risk is always in terms of quantity. Okay? How much in terms of dollar? How many people? Right? It's not a qualitative risk assessment also you can do, but ultimately we want to have actually quantitative risk assessment. Okay? Again, if I try to break it down, hazard is the temporal probability, right? Temporally, when, and the vulnerability and amount is the consequences of losses. Okay? So that means temporal probability multiplied by the degree of loss to the elements at risk multiplied by quantification of element at risk. Okay, I think this is not rocket science, right? It's very easy. You have solved much more complicated equations. Okay?
Sir, one
Yeah.
question is there.
Hmm.
So when we are addressing this issue at a degree of loss to element at risk, now sir, elements like human death, death tools. So how do you put an amount on that?
No. Human death, you don't put amount.
So when that comes into this risk framework,
Yeah.
how do you?
Okay. I'll give you a very simple example. Now, I think I did mention this simple example to you one of these days. You are the only wise owner for the family. Okay? Now, you are going to work every day and you are driving your car or maybe motorbike. Let's say motorbike. You take a particular road going to your work, and your whole family is depending on you. You are the only breadwinner for your family. Now, if I have to do a hazard assessment of flood or any kind of hazard assessment of that area, and when it comes to that road, obviously, if there is, let's say, landslide is going to happen, these factors has to be factored in when I would like to be at the risk. Okay. Now, your annual income, let's say, 5 lakhs. Assume. Oh no, you are not happy.
Doesn't matter. Sir. You can make me a millionaire.
50 लाख ठीक है मान लो 50 लाख ठीक है मैं utilize this too much because the equation is okay, so let's say 5 lakh ठीक है. Now when you are traveling there, let's say, and if there is any likelihood occurrence of the landslide, and if you are being hit by the landslide, there are many consequences. Many consequences could happen. Consequence number 1, I hate to say, life loss. Okay, finish, and the family is gone. You can't even quantify, right? Okay. Consequence number 2, partially or fully incapacitated. Okay, again, when you say that, the losses of your future incomes are going into trade, right? And the people who are affected by you also, that need to be counted for. That is how the insurance comes in. Okay? So the loss of life is just one of it. That is a direct loss. But then there are indirect losses. Or maybe now you are injured. You are injured for a certain duration of time. Let's say about a month, bed rest. Okay, for insurance, or maybe your company is very good, they say, okay, never mind. We'll pay you, you are still there. You are still with us. But now the company says, no, we need someone else replacing you. Then there will be again another scenario will come, to find another job. So you see, the consequences can be different and affecting your family. Right? Now you understand? That's how we estimate the. It's not about just the human loss. It's also the direct loss and the indirect losses. The losses that is coming from the future probability of income. Right? Understand? Good. So now you see here, you have hazard. Hazard, you have temporal probability, hazard intensity. Okay? All those factors have to go in to do the hazard assessment. Then you do the vulnerability. Vulnerability is very straightforward because you take the socioeconomic parameters. That means the most important or the more weighted should be always given to the life. That's it. Because at the end of the day, life is the most precious thing. And 0 losses should be non-life. That is should be our aim and target. Okay? Then comes actually the dollar values. That means if it is a house, I'll show you some example. If there is a house, not only the cost of the house, but the reconstruction of the house, but also the content of the house. In India, we don't have actually insurance for the house, right? We have?
Yes.
Huh?
Yes.
So someone saying yes, someone saying किसके पास है इंश्योरेंस, घर का इंश्योरेंस किसके पास है, अपार्टमेंट है, देर है कैसे, और तुम्हारे घर पे जो कंटेंट है